Hey scientists, welcome back. I'm Jessica Power, one of the science curriculum coordinators at Kansas Public Schools. Last week we read a book called Ada Twist Scientist, and we learned all about this curious young scientist named Ada. And scientists, if you remember at the very end of the book, Ada had written all of her information and observations all over the wall in the hallway. And her parents were like, I don't know what we're gonna do. Well, her parents came up with a great solution. If you remember in the book, her parents had created that paper roll that was really, really long, went from the ceiling to the floor, and Ada was able to stand on a ladder and cover the whole paper with her observations and her data. Well, today, scientists, we are focused on data. Now, being a good scientist means that we have to be able to collect, analyze, interpret, and make connections of data. Data can be observations, measurements, it could be simple tallies for trials. It can be comprised of lots of different things. So we're going to use another book this week, scientists, to help us out with data. We're going to read a book called Exemplar Evidence, Scientists and Their Data by Jessica Fries-Gaither. Now in this book, you're going to be introduced to many scientists throughout the Earth's history. And in fact, each and every scientist used data in order to help them draw conclusions or make new discoveries that we now know today and still hold to be true. So let's get to it. As you listen today, scientists, I want you thinking about how can you, as a scientist this year, use data to help you learn and make sense of the world around you in science. Here we go. Scientists ponder, question, and wonder about all kinds of subjects from flowers to thunder. But no matter what the query is about, a scientist's job is to figure it out. How do scientists find out what is true? They need to have data, and lots of it too. Data can be tallies, measurements, numbers, or notes and sketches of amazing wonders. So data doesn't have to be just numbers. It can be drawings and sketches and labeled pictures. You can gather data through experimentation, a process that can lead to much calculation. So measurements must be precisely taken. When it comes to data, you can't be mistaken. How far did that travel? How fast did that go? Answering these questions gives data, you know. Timers and rulers, balances and more, data is collected with tools galore. Afterward, there's just one thing to do. Analyze the data to find something new. By comparing, graphing, looking for trends, what will it tell? Well, that depends. No matter the data, there's just one aim. Gather enough to make a strong claim. Data is evidence for what's thought to be true. It is the foundation of what scientists do. The importance of data is shown rather well by work of scientists too many to tell. Throughout all of history, data's been key in the making of every great discovery. Hazen lived in Egypt 1,000 years ago, yet still is important for what he did show. A groundbreaking study not hard to understand, investigations need not always be grand. In a darkened room, 2 lanterns shone light, each one of them hung from a different height. On a far wall, 2 bright spots could be seen, each one of them formed by the lantern's strong beam. If he covered a lantern, the spot became dark. This simple finding ignited a spark. Light did not come from our eyes, as believed. Instead, it came from the source, he perceived. Hazen went on to complex topics and even wrote 7 books about optics. He remembered all as his methods was clear. He was the first to use data to support his idea. The power to show that an idea is untrue. It's amazing what collecting data can do. Marion's data took another form. In fact, her life and work fell outside the norm. During her life, she painted insects of all kinds, traveling far away to see what she could find. Not much was known about insects or how they grew. Where did they come from? The answer, no one knew. Some popular ideas included mud, air, and rain, Exactly how this happened, no one could explain. Marion kept caterpillars, she watched them grow and change, even though to others her studies seemed quite strange. Through her colorful paintings, she could document stages of a life cycle and what those changes meant. Marion's work was remarkably complete. To show such detail was really quite a feat. This precision helped others see the lives of insects from butterflies to bees, the power to develop a new point of view. It's amazing what recording data can do. In the 1800s, new elements were found. These discoveries seemed to be all around. Chemist Dmitri Mendeleev had a gut feeling that organizing their data would be quite revealing. Upon cards, he wrote each one's information, then tried his hand at organization. After many hours, he fell asleep at his desk, but when he awoke, he knew what to do next. He arranged the elements by order, by height, by weight, and knew he was onto something quite great. Chemistry was changed by his development, Mendeleev's periodic table of elements. The table wasn't just a success on its own. It predicted elements before they were known. It also pointed out some errors in weight. Unfortunately, the records could now be set straight. The power to predict something entirely new, it's amazing what organizing data can do. In Havana, Cuba, the situation was dire. Deadly yellow fever was spreading like fire. Outbreaks occurred time and again, if only doctors could predict where and when. Carlos Juan Finlay was up to the task. As a family doctor, he just had to ask. His patients' histories provided him clues. The data was easy to collect and to use. He looked for patterns, and with some good reason, most outbreaks occurred in the same season. From his data, he inferred the link. Mosquitoes spread the disease in a blink. Sadly, his ideas weren't accepted for years. The mosquito hypothesis fell on deaf ears. Finlay persisted until others agreed that mosquito prevention was definitely need. The power to stop diseases and prevent them too. It's amazing what comparing data can do. Nettie Stevens studied mealworms in great detail to find out what made them male and female. By using a microscope to observe DNA, she had collected data that we still use today. Peering through her microscope, Dr. Stevens saw two different chromosomes, one short, the other tall. Male mealworms consisted of one of each kind. Females had two tall ones, a finding surprise. It was the chromosomes, Dr. Stevens did declare. The sex of the larva was determined by the pair. Two of the same meant girl mealworms would be seen. One of each, boy mealworms, determined by their genes. This work was the first to link chromosomes to traits. Her clear observations would set the book straight. All along, data hidden from the naked eye showed females were XX and males were XY. The power to understand what's out of view is amazing what sharing data can do. Dr. Ruby Hiros, a chemist, had a brilliant mind. Her data was quite different kind. She conducted experiments on blood and cells, collecting data to keep us well. She suffered from an allergy known as hay fever and studied ways to improve a reliever. Adding a new substance to make it work well was a discovery of which others would tell. She contributed to other studies too. A vaccine was the goal for the work that she'd do. To prevent a disease called infantile paralysis, her data would need some careful analysis. Dr. Hiro's work did not go unseen, such important studies being anything but routine. At a meeting of chemists of great acclaim, she was one of 10 females mentioned by name. The power to improve lives through and through, it's amazing what interpreting data can do. Down deep in the ocean at the bottom of the sea, Marie Tharp wondered what there might be. A few scientists care about that, for they assumed it was boring and flat. No one could travel there, she had to concede, so how could they get the data they needed? Sonar was used, a great innovation, to measure the depth of underwater locations. She couldn't go to sea, she stayed on dry land, plotting out thousands of soundings by hand. Tedious work, but she and her partner pressed on, consulting the data for what should be drawn. Mountain ranges and valleys began to take shape. It was an entire underwater landscape. The map she created of the whole ocean floor, used to prove others' theories and more. The power to change our current worldview is amazing what visualizing data can do. You can see her mapped out ocean floor, how it changes, there's a little mountain here under the ocean. Our human bodies are quite complex. Their intricate workings can often perplex. Dr. Marie Daly advanced our understanding. Her work and findings were truly outstanding. At first, she studied the process of digestion and then moved on to a more pressing question. What caused heart attacks? She wanted to know. The answer she hoped her data would show. Dr. Daly analyzed data from many a patient and finally came up with an explanation. Many with high cholesterol had suffered an attack. Their arteries, it seemed, were clogged with plaque. This wasn't the only conclusion she would draw. The effects of cigarettes, something else she saw. By connecting smoking with lung disease, Dr. Daly saved lives thanks to her expertise. The power to build knowledge and improve health too. It's amazing what analyzing data can do. In places where coal, silver, and oil are found, these precious resources are under the ground. How do you know this when you can't see? By using data to predict where they'll be. A geologist in Montana can make such a claim. Dr. Russell Stansover Bull is his full name. Born and raised a proud member of the Crow Nation, his expertise lies in mapping resource locations. Finding these deposits was joy without measure. To him, it was hunting for deep buried treasure. Without the right data, it'd be difficult to know exactly where a well or mine needed to go. He wanted to do more to help his hometown, so he founded a company in that small town. Its purpose to help other tribes understand how to develop resources on their own land. The power to find resources and help others too. It's amazing what mapping data will do. Scientists use methods to explore, doing their work on land, sea, and shore. Despite all their efforts, at the end of the day, without the right data, there is not much to say. John Snow used data to stop a deadly disease, and Gregor Mendel got lots of data from peas. Data helped Vera Rubin make a strong case for the existence of dark matter throughout space. Data supports conclusions. It changes people's minds, but it's used to build theories that help humankind. Scientists all along have known this to be true. Data is powerful. Now what will you do? Scientists, that last page mentioned that data supports conclusions. You know how when you're writing a paragraph, you have your opening sentence, and then you have details within that paragraph? Well, scientists, data is the details. When we make observations or make measurements or record how many times something happens or write down what happens during something, the cause and effect, that's data. That tells us as scientists what's happening. Now we get to take that data and analyze it. That means we want to go through it very carefully. We want to find patterns. We want to find connections. We want to interpret that data and make sense of it. We want to understand what is happening throughout our observations. Now, usually, a scientist starts with a scientific question. Like, why does the sun rise and set? at different times during the course of the year? Or why is there more daylight during the summer and spring than there is in the fall and winter? Scientists, these are great questions that we can use data to find answers for. For example, if you wanted to find out why there's more daylight during the spring and summer than there is in the fall and winter, you could every day record the sunrise and sunset times along with how many hours of daylight we have on Earth each day. Now, after you've gone through that data and collected that data for a certain period of time, I don't know, 2 months, 3 months, a year, you can then start to see patterns. And you'll start to make sense of things. And then maybe that'll interest you into finding out why seasons occur. Why do we have seasons? And what are the connections between seasons and sunrise and sunset times? I'm getting ahead of myself, scientists. This isn't my science project. This can be your science project. So this year, scientists, as you're learning about different topics in science, have a science notebook. Record your questions, and with the questions you have, take an opportunity to make observations, collect data, make measurements, tally different things, use numbers, see what conclusions you can find in the data that you collect. Thanks for hanging out with us, scientists. It was great to see you. I'll see you next week. Have a good day.